So the last section we're doing is section 3 is separation of variables in logistic equation. We've already talked about separation of variables, and we've already talked about the logistic equation. So hopefully this isn't too bad for you. There is some complicated stuff going on here though, so we are going to take a look at slope fields again in this section just to kind of drive home a couple of things that happen with these types of equations, which you'll see here in a little bit. But first of all, take a look at the differential equation that's in this form. We have some function sitting here in terms of x, and then another term, and that function is in terms of y, and then the dy over dx is attached to that term that has the function in terms of y, and it's all equal to 0. If you have a function in that form, then you can perform a separation of variables to solve the differential equation. Very exciting. So what's going to happen here? If you want to do a separation of variables. Move this guy over, right? Okay, so now this is over here, then what? Basically, that dx has to go to the other side as well, okay? It's not really times by, we think of it as, but that's not exactly what's happening there. So I just got to keep saying that because I'm not teaching you the wrong way, I'm teaching you the shortcut. So that's it. That's basically what we're going to be doing for the first portion of this section. So we have 3 practice problems here. Rewrite the differential equation with the variables separated. That first one is really straightforward. What do we do first? Subtract the x squared, yeah. Oh yeah, there should be an equals 0 here, sorry. Subtract the x squared from both sides. Equals negative x squared, and then, right. So we wind up with 3y dy equals negative x squared dx. And that's all the problem asks you to do, so that's the answer. Normally from here, of course, we could integrate or whatever, but that's it. How about that second one? If you divide both sides by sine x, then you're left with y prime on the left, right? What is y prime? Yeah. So we have dy over dx equals cosine x over sine x. Okay, good. Cotangent x. So then one last thing to do. Dy equals cotangent x dx. And again, that's your answer. You guys think you're so smart, let's do that last one on your own then. What's the first thing we should do? After that? No. Y prime is dy over dx, right? So I don't need this y prime, I need dy over dx. So now the issue is I need to get x on this side and the dx on this side. If I put the y on the other side, then I got to divide by dy, which gives me 1 over dy, which I don't know how to deal with. The dx is the thing that has to go, which means the x is the thing that has to go. So that means I need to divide both sides by x. And when I do that, I have 1 over e to the y plus 1 dy over dx equals 2 over x. And now I can just move the dx over. 1 over e to the y plus 1 dy equals 2 over x dx. Okay, find the general solution. I tell you, we got to separate and integrate, which is what we've been doing. So on these problems, there is going to be something called a trivial solution sometimes. And the trivial solution occurs when y is equal to 0. When y is 0, then x can be anything it wants to be, and we still wind up with a slope of 0. The trivial solution is like basically the x-axis. To figure out if the trivial solution is there, you need to substitute in 0 for y and see what happens. If I plug in 0 for y right here, then I'd wind up with equals 0. And at that point, I could divide both sides by the x squared plus 4, and I wind up with dy over dx is equal to 0, everywhere that y is equal to 0. And that's why it's called the trivial solution. So this is probably something you need to write down. If y equals 0, you can solve and wind up with dy over dx equals 0, regardless of what x is. This means that y equals 0 is the solution, and that is a trivial solution, because it's just like when people want to multiply both sides of the equation by 0. All it does is wipe out the entire equation, and it doesn't do you any good. And that's what's happening here. All right, so let's do a separation of variables here, and then we'll integrate from there. So what do I need to do? So how do I do that? Divide both sides by y, so now I have 1 over y. Divide both sides by the x squared plus 4, so over here I have x over x squared plus 4. So that leaves me with the dy over here and the dx over here. Off to the side, let's say I just divided by this x squared plus 4. So this is just an aside. Dy over dx equals xy over x squared plus 4. Now, dy over dx is what? Yeah, the slope. So if this is the slope, then if y is equal to 0, then I wind up with 0 in the numerator. 0 divided by anything in the denominator just gives me 0. I just get 0. And that's why this is called a trivial solution. I wind up with a slope of 0 always. So if I have an x-coordinate and I plug it in, if y is equal to 0, I'm always going to have a slope of 0, which is pointless. It doesn't do us any good. I'll show you in a little bit the slope field, and maybe that'll probably make more sense. Anyway, that's an aside. Here we are here. What do we do? Integrate. So what do we get on this side? The natural log of, okay, equals 1/2. Where'd the 1/2 come from? Yeah, that's right. We have almost a u prime over u situation here. We need a 2 there, which means I need a 1/2 out front so that when I integrate this, I do have the u prime over u. So that makes 1/2 what? Natural log. I'll put it in anyway. X squared plus 4 plus c. All right, now you notice that we don't need the absolute value here because no matter what, when I plug in a number, I get a positive result plus a positive number gives me a positive, so I don't have to worry about absolute value there. What about the absolute value here? Yeah, I do have to worry about that. So, what could I do next? Put the parentheses in there for it. Why are you trying to move the natural log? We're trying to solve this equation for y. No. The directions say find the general solution. The general solution is solve for y most of the time. A base EV. Well, what about that 1/2 that's sitting out front? Make it an exponent. This 1/2 can live as an exponent over here, and then we don't have to worry about it anymore. So now we have the natural log of the absolute value of y equals the natural log of x squared plus 4 to the 1/2. To the 1/2 power means square root. So I can actually just make this a square root plus c. Now base e. So I put an e here and an e here, and what do I get? The absolute value of y equals square root of x squared plus 4, not plus c. Yeah, it's plus e to the c, or times e to the c. The reason for that is when you have e to the natural log of the square root of x squared plus 4 plus c, we're adding two exponents, which means what we really did was multiply like bases together. So that becomes e to the natural log square root x squared plus 4 times e to the c. So this simplified to that, and then I still have that e to the c. And what is e to the c? Yeah, it's just another constant. So really I could have been calling this c1 the whole time. And then when I make e to the c1 just a constant, then I can write c out front. So now I have the absolute value of y equals c square root x squared plus 4. How do I handle that absolute value? Yeah, there's the positive case and the negative case. The absolute value written like this basically makes a plus or minus over here. So what I really have is y equals plus or minus c square root x squared plus 4. So now the thing is, how do I deal with the plus or minus? And actually, because of the fact that we had this trivial solution up here, y equals 0, what happens is when you take a look at the slope field, which we will here in a minute, when you take a look at the slope field, that trivial solution, y equals 0, if this is my graph, then I'd wind up with a slope field that has horizontal ticks going through the x-axis like that. So now if I have an initial condition or some sort of given situation up here, my graph will not cross because of this horizontal case right there. My graph is prevented from crossing. Or if I start out down here, again, my graph is prevented from crossing. So because of that, I actually don't need the plus or minus. So my final answer is y equals c square root x squared plus 4. This is the slope field for that original differential that we were looking at. Rewritten like this, you can plug in xy divided by x squared plus 4 into your calculator and see that we do sort of look like we have a horizontal slope going through the x-axis. As we get closer and closer to the x-axis, it's going horizontal from both sides. So you wind up with this horizontal slope field going through the x-axis the entire way. That prevents me from having a graph that goes through the x-axis. So if I were to put an initial condition in there, you would see probably some sort of parabola-looking shape here on one side, or some sort of parabola-looking shape on the other side. However, you would never come up with a graph that actually crosses. So that's what's meant by the trivial solution. Okay, so back to the question that you had. Let me adjust this. Sometimes it isn't possible to write your solution in the explicit form that we wrote the last one in, like solving for y. When that happens, perform your separation of variables and integrate, but then leave your answer in a separated form. And there's usually going to be a clue for when a problem like that is what's going on. You'll have notation that looks like this. They'll say given y at 0 equals 1. The reason they're doing that is because this is, well, first of all, this is a clue. This is kind of like function notation, but it's not really function notation. If it was function notation, you'd see f at 0 equals 1. But they're saying y at 0 equals 1, kind of using the idea of function notation. But they can't write f at 0 equals 1 because it's not a function. It doesn't pass the vertical line test if you were to graph it. There's y's involved on both sides of the equation. So they have to go with a notation that looks like that. That's the clue. That tells you that once you have integrated, you will not need to solve for y. That is an x right there, and that is a y. So they're telling you an ordered pair, 0, 1, is a solution in that equation. Okay? No. This is like f of x equals 1, but they can't say f because it's not a function, so they say y. But it's still the same idea. This is an x coordinate, this is a y coordinate, just like normal. So they give you that so that you can find the particular solution once you find the general solution. All right, so we have this really ugly looking xy dx plus e to the negative x squared times y squared minus 1 dy equals 0. It's nasty looking. We want to get our variables separated so that we can integrate this. And we're going to take a look at the slope field of this as well. Okay, so for sure this thing needs to go over here. Okay, so now we have e to the negative x squared times y squared minus 1 dy equals negative xy dx. Now what? Divide both sides by y. Because of this y on the wrong side, it has to be over here. But also, the e to the negative x squared. Divide both sides by e to the negative x squared. So we have what?
Y squared minus 1 dy over y equals.
Okay?
But
Not yet.
because of that negative x squared, we can rewrite it as 1 over x with the second fraction.
What about the left side? Split it, yeah. So we can split this into what? Y minus 1 over y dy equals, and now we'll do what you were suggesting. With this negative exponent, that actually is a positive exponent in the numerator, so it's negative x times e to the positive x squared dx. Now we can integrate, but before we do, I want to go back and take a look and see if we have a trivial solution here. If I plug in 0 for y, what do I get? Over here, notice what happens if I plug in 0 here. It's gone. If I plug in 0 here, 0 here, what do I get? So it's negative 1, or negative e to the negative x squared, dy equals 0. No? So actually, there is a trivial solution here. If you're to solve for dy over dx, if we go back to here, and I were to move the dx back over here, and then I take this and divide both sides by it, then I have the negative xy over the e to the negative x squared times x squared, or y squared minus 1 in the denominator. If y is 0, the numerator is 0. The denominator is not, but it doesn't matter. It's the numerator that became 0. So the dy over dx became 0 when y was 0. So that means no matter what I plug in for x, if y is 0, I'm going to get 0 as my slope. So there actually is a trivial solution here. I'm actually going to write, note, y equals 0 is a solution. And you really need to understand why that's the case. Now here's the issue though. Y equals 0 is a solution, but because of this initial condition that they're giving you, it says when x is 0, y is 1. That gives me an ordered pair that breaks this. It takes me off of the x-axis. So it does not, but y equals 0, so it does not. satisfy the given condition. Y equals 0 is a trivial solution. That means that no matter what I plug in for x, I get 0 for y. But here it's saying I can plug in 0 for x and therefore get 1 for y. And if that's the case, then I don't have to worry about the trivial solution. I won't get the trivial solution because I'm going to plug in this ordered pair right here. So let's go back to the problem that where we were at. What do we do now? Integrate. So integrate both sides. And what do we get on the left side?
1/2 y squared.
Okay, y squared over 2. Minus the natural log of the absolute value of y. How do we integrate that? Do a u substitution. U in this case would be x squared.
Oh. So you just pull the negative out. And we have u prime times e to the u.
Is it e to the u? I think we better write this one down off to the side. So we have let u equal the exponent, x squared. So then what happens? Okay. I need to solve for x dx because I have this x dx right here. So 1/2 du equals x dx. That's an equal sign. I got that negative sign in there. That can be pulled out. And then I have the x dx, which turns into 1/2 du. So this is actually negative integral 1/2 on the outside e to the u du. Well, I have that negative 1/2. And then the integral of e to the u is just e to the u. So that's e to the x squared. We done? Yeah, don't forget the plus c. Okay, now what? Solve for y. This notation right here kind of clues me in that I don't need to do that. At this point, I can plug in that ordered pair that they gave me. They say y at 0 equals 1, which means that y at x is equal to 1, which means that x is 0 when y is 1. So I can plug in 0, 1 into this equation. So over here, I'll write since y at 0 equals 1. I'm kind of writing this like a free response type response. You would want to have that on there. You would want to write that. It's showing people that you're thinking as you go. So now I can substitute in 0 for x and 1 for y. So as I go, I have, so 1/2. What about this? What's the natural log of 1? Yeah. So 1/2 minus 0. Okay, equals what? E to the 0 is 1, so that's actually just negative 1/2, and then plus c. 1 equals c. Y squared over 2 minus the natural log of the absolute value of y equals 1/2 e to the x, negative 1/2 e to the x squared plus 1. Now you could see an answer written like that more likely. What they're going to do though is multiply through to get rid of the fractions, which means I'd have to multiply this equation by 2. So I'm going to go ahead and do that. and wind up with y squared. And here's y. Minus what?
Natural log of
Yeah, so I have y squared now, right? Because it was 2 natural log absolute value y squared. But if I'm squaring a number, it winds up being positive. So by doing that, I actually get rid of the absolute value symbol, and I can just write minus the natural log of y squared equals plus 2. And finally, let me slide this down a little bit so I can get some more room. This isn't quite the answer yet. We want all of the variables on one side and the constant on the other side. So it's going to be y squared minus the natural log of y squared plus e to the x squared is equal to 2. There's your answer. Next problem, find the equation of the curve that passes through the point 1, 3 and has a slope of y over x squared at any point x, y. So this is a different way to show you a problem like what we've been working on. What does the slope of y over x squared at any point tell you? Yeah, dy over dx what? Equals y over x squared. That's correct. Before we do that, is there a trivial solution?
Yeah.
Yes, there is. If y is equal to 0, then you wind up with a slope of 0. So there is a trivial solution here. Not only that, there's something else we need to see. If x is 0, there's a vertical asymptote. Yeah. So we have, like if I just draw in a little sketch here, as of right now, we have a trivial solution, y equals 0, which gives us a horizontal, basically like a horizontal asymptote there. So I am going to say y equals 0 is a trivial solution. But I'm also going to say x equals 0 is undefined. So what that does is it gives me a vertical asymptote there. Which means before I generate an equation or anything, no matter what, I'm going to be restricted to either one of these 4 quadrants. And because my ordered pair is 1, 3, I'm going to be restricted to the first quadrant only in my graph. So knowing that, if this is a multiple choice question on the AP exam, you could solve this problem fairly quickly by eliminating answer choices that showed you graphs in either one of these 3 quadrants with that given initial condition. All right? So you definitely want to be able to do that sort of analysis. It can save you time. Separation of variables. So I kind of wrote over where I was going to write, but what do we do? So I got to divide both sides by y, and then get the dx on this side. I wind up with 1 over y dy equals 1 over x squared dx. Looks pretty good. Now what? Integrate both sides. What do we got on the left? Good. Natural log, absolute value, y equals. There's no need to do a u substitution here. This is a straight up integral. There's no rules to follow aside from like the power rule. What do we get? No. X to the negative 1, which is 1 over x. But we have to divide by the new exponent. So it's actually negative 1 over x plus c. So don't get so wrapped up in these rules that we've been working on the last couple of months. Make sure you still remember that this can be rewritten, and then that's a straight up integration process. Add 1 to the exponent, x to the negative 1 becomes 1 over x. But then you got to divide by your new exponent, which was negative 1, and that's why we wound up with that. All right, now what do we do? How about we solve for y? Why are we solving for y here? We're finding the particular solution, which we kind of did on the last problem, but I'm not giving you something like y at 0 equals, or y at 1 equals 3. I'm giving you a straight up ordered pair. That's a clue that I'm probably solving this for y. And by the way, that's not very hard to do here. What do we need to do? Base e on both sides, and what do I wind up with on the left? Okay, the absolute value of y equals e to the negative 1 over x plus c. I'm just going to do that for now because there's more simplifying that we can do here.
Can change absolute value to plus or minus on the right. But it would,
There you go. Remember this analysis right here. We know that we're going to be stuck in that first quadrant. So there actually is no need for the absolute value here because our y coordinates are always going to be positive here. So I do not need the absolute value. Y equals, what do I do with this? Okay, so I have what? Times e to the c, which is just c. So I'm going to write c, e to the negative 1 over x. Right, we have this ordered pair that was given to us, so we're going to plug in our numbers to get our particular solution. So I write 3 equals c e to the negative 1 over my x coordinate, which is 1. So that's e to the negative 1. 3 equals c e to the negative 1, which is like c over e. Don't need a calculator for it. Solving for c, 3e equals c. So now my general, or my particular solution is y equals 3e times e to the negative 1 over x. And that's it. Now I want to say a couple of things here. First of all, we go back up to the stuff that we had here, and we did have to include one thing. X can't equal 0. Which actually showed up in our answer pretty conveniently right here. We can't have x equals 0 there. Okay, and also remember that x is restricted because of this initial point that we were given. X is restricted completely to the first quadrant, and also because of the y equals 0 being a trivial solution here. So I do want to take a look at the slope field for this. So let me get that set up. All right, so here you go. You can, if you take a look at this, you can kind of see how there is a horizontal asymptote going through the x-axis, and also it does appear that this thing takes off as it approaches the x-axis from the left side. As it approaches the x-axis from the right side, it does also look like it kind of gets sucked into the origin here, but it will not go beyond that. If I put in, if it will let me put in an ordered pair here, we'll see. Probably won't. Oh, it does. Good. And it was 1, 3, right? And there you go. So it will not let me cross. If I put one in over here, it will not cross either of these axes. It does stop dead right here. It gets kind of sucked into that place where the thing is undefined completely. And then that's it. So the math doesn't lie, but when you look at the slope field on the graph, I think it kind of makes it more clear. Anyway, that's how you do a problem like that. Okay, an applied problem finally. The rate of change of the number of coyotes, n of t in a population, is directly proportional to 650 minus n of t.
Were the coyotes down by the creek?
The coyotes were not down by the creek. They were on the roof. Where t is the time in years. When t equals 0, the population is 300. When t equals 2, the population has increased to 500. Find the population after 3 years. Yes, so you're seeing ordered pairs already. But the thing that you need to see is this word, or this phrase right here, directly proportional. So that's going to set up a lot like the problems that we're doing in section 2. It says the rate of change of the number of coyotes is directly proportional. What is the rate of change? Normally dy over dx, but in this problem, dn over dt equals, now directly proportional means that I have a k times whatever it's directly proportional to, which in this case was 650 minus n of t. Not n of t, just n, sorry. This is supposed to be just n. Separation of variables first. dt over here. Yes, 1 over 650 minus n in the denominator there. dn equals k dt. So the right side is easy. The left side is not necessarily easy. Okay, integrate both sides. If only we had a negative on top. We'd need a negative out front, and now we do have u prime over u. Good. Equals. Plus c. I could call that c1. I probably should be calling that c1. But anyway. No. Solve for n, yeah. So first of all, notice that we have this negative sign sitting out front here. I can send it to the other side. So now I have the natural log of the absolute value of 650 minus n equals negative kt minus c. I'm still going to call it minus c. Before that, 650 minus n. What is n? The number of coyotes. It can never go negative. So do I need the absolute value? No. Now I can apply e to both sides and wind up with 650 minus n equals e to the negative kt minus c. There you go. All right, now we do have the ordered pairs. Oh, solve for n?
Yeah.
You're not going to let me get away with that?
No.
Okay. So solve for n.
Minus 650
If I move the n over here, and then I move that over there, and then I flip everything using the symmetric property of equality, then I wind up with n equals 650 minus c e to the kt. Negative kt, thank you. And then we can substitute in some ordered pairs. So give me an ordered pair to substitute in.
We have 0, 300.
When time equals 0, the population is 300. So if I put in 0 right here, I have just c e to the 0, which is just 1. So I have 300 equals 650 minus c. If I add c to both sides, subtract 300 from both sides, I get c equals 350. So, okay, now I have n equals 650 minus 350 e to the negative kt. My other ordered pair?
2, comma, or 500, comma 2.
2, 500.
Was that 2 years? Okay, so 500 equals 650 minus 350 e to the negative 2k. All right, well, I subtract 650 from both sides. It gives me 150, negative 150. Divide by negative 350. It becomes positive again, 15 over 35. 3/7. So we have 3/7 equals e to the negative 2k. Natural log both sides. Natural log 3/7. I can then divide by that negative 2, and that gives me my k. So I got to type that in my calculator. And what do I get? Positive or negative? Should be positive. 0.42, you said 36? So 36. Okay? So now my equation is n equals 650 minus 350 e to the negative or positive?
Well, no, it's negative k, so negative.
And we want to find the number of coyotes in 3 years, so I'm just going to plug in 3 right here. And we'll type all that in, and we get I'll end the suspense. 552 coyotes. So there's your answer.